All right, then. I need you to give me some colors. Okay. It's the same thing as reactive. And because I said metallic, am I talking about reactive with metals or non-metals? I'm talking about metals. Okay? If I had said the most non-metallic, I'd been talking about non-metals. Okay, we're done? All right, I need to give Lolly and Caroline a homework paper because we had one more worksheet I did not give y'all yesterday.
Oh, I got that.
Oh, you got it? All right.
Is that the paper you gave us in the morning?
No.
Number 3?
It's number 3, yeah.
Yeah.
And I'll hand out papers. Oh, my homework. Put on my laptop there.
Ms. Wall,
Yes, ma'am.
can Owen Beasley to the office for a moment?
I will.
Thank you.
All pass. All right, so on the one I just handed back, there were multiple hundreds. The two that were most missed were number 14 and 17. All right, they were backwards. You use the online resource. They're switched on there. Get y'all in here with that one. If you read clue 14, it says the 14th room is on the 3rd floor. What do you suppose the 3rd floor means? Third period. Let's do something third period.
Whoops.
Well,
I didn't know what that meant. So.
That is good.
That's what it means. That's what it is. I figured you would. Although most of the clues are pretty easy, so why did you need?
Not really. Those are the two that I got stuck.
It was late. I found the quiz
Yeah.
and I was like, ha.
And
And I like neither one of them.
Wait,
something there.
I told her that you struggled.
I even got to say, Laura, like, can you help me translate this?
Okay, I
I tried really hard.
know. I was I figured.
The arrows just
No, I
just lost me.
I just started giving up.
I mean, I tried really hard to find all your answers.
Wait.
Wait,
If I find them, do I get credit or do I?
If you can find them and they're right, maybe we're great, okay?
Wait, what was the
I had to write
them.
The only one that I think could possibly be right
It's 2.
is, no, two, but I'm pretty sure it's wrong, is this one. I'm looking for the word period.
Right here. Periodic table.
I just wanted the word period.
And then here I said it was periodic.
I'm looking for transition elements. Did you tell me transition elements?
No, I just said element based on like my.
Nah, that's wrong. I'm just looking for the word period. They're separate into sections called periods.
You guys get it.
Would you? I gave you the nation.
Like a big ass me.
All right, on this one, number one was periods, which the vast majority of you got without difficulty. Number two, I gave you some leeway if you use the numbers. There was some play in number two in creating the list. The right answers for A, the smallest should have been noble gases. So it should have been helium, neon, argon, krypton, and xenon. However, if you went strictly by the numbers and you had helium in that list, I gave you credit for that. For the largest, if you had helium in that list because you went by the number, I gave you credit. But it should have been helium, lithium, sodium, potassium, and ruthenium. If you went by the numbers and you had ruthenium in that list, I gave you credit for that also.
Wait, why does I have an H and a -1? And the X and a
It depended on what number or what elements you had in the list. You only had 4, and there should have been 5 because there were 5 sections, and you only had 4 in each of your lists, if I remember right. So I added 2 elements to your list for yours. All right, number 1 at the bottom should have been decrease. The reason is, as long as you told me something about protons increasing, I gave you credit. Most of you had something about protons increasing. If you said anything about shielding, I gave you credit for that too. Number 2 should have been the transition elements. The reason is the number of intershell electrons remain the same. Number 3, within a family, they will increase, and that's because the number of energy levels increase. Most of you who got that right told me about the quantum number increasing, which is 5 also. Questions? Okay. All right, homework from last night. Did I give everybody one who was absent? I know Molly was because she was out testing. Caroline said she had one. Oh, you have homework? You don't have Dylan? All right. All right. Answers to the homework. Number 1. Which metal is least reactive? Who'd you pick? Why? Why didn't you pick gram or magnesium? It's in group 2, and aluminum's in the P block. P blocks are less reactive. All right, which non-metal is least reactive? S. All right, it's in group 16 and fluorine is in group 17. Group 17 is always more reactive. All right, which element has the smallest ionization energy? Cesium, A. All right, who is the smallest? +1 means it lost electrons, so it's going to be smaller. Which element has the largest radius? Radium, Ra. Which element has the largest ionization energy?
Iodine?
Yeah, bromine. Bromine.
Wait, does it go up as you go up? Wait.
It's bigger as you go up. Helium has the biggest, so Br is closer to helium. All right, where am I at? Highest melting point. What's the highest melting point?
AU.
AU, D block. The gold. AU. All right, number 8. Who has the smallest density? Nope. Why is it oxygen?
Wait, what?
Oxygen. It's a gas. Gases always have lower densities than metals.
Wait, but that goes against the trend.
No, it doesn't.
Yeah, it does. It always was on metals.
It's a trick question.
I
And wait, no one else tell me that.
What?
Gases are always gonna be less dense than metals.
Okay,
I brought some of those little expression things to some big gas.
Huh?
It said thick gas. On the expression. I'm not crazy.
Okay. Oxygen is a gas, okay? It's the gas is in this room that we all breathe. Is it really gonna be more dense than a metal?
You really told us no element though, so.
I really did, but, you know, I really thought, I know, Caroline tells me all the time, her family says she has her common sense. I mean, I thought we could exert a little bit with the question, but clearly not. All right, oxygen is a gas, it's less dense than any metal. I thought I was safe putting plain old oxygen in a question. Clearly I should not have done that. Huh? Okay. I did not lie to myself on the quiz or the test. I did not do that. It's just on a practice sheet. Okay, Doctor? Okay, I did not do it on a test or a quiz. But oxygen would be less dense than any kind of metal. Just saying. All right?
Any type of gas.
They would be.
Okay.
Okay, I just gave you one that I thought everybody would know. Clearly not. All right, number 9. Who has the smallest radius? Yes. All right, which element has 5 outer shell electrons? Yes. Who has the -2 ion? Yes. And B should have been capitalized. That's quite good. And which element will not gain or lose electrons? Yes. Questions? Fabulous. All right. So a lot of you said that you want to make up the lab? Yeah. ABL? Yes. So you two want to be left out of the lab. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 17. All right, so 17 people. So I got an odd person.
You could count me
Oh, you don't want to do it either?
out.
Huh? So you want to make it up? So I got 16 people. All right, group of 2.
Oh, shit.
Let's do that.
Oh, who's gonna be my partner?
Yeah, Jesus is on your side.
Jesus is always by your side. He's always here.
Yo, she was on yesterday, and there was a bunch of Mexicans in the car, in a pickup truck, and they had 2 hanging Jesus on the other side.
I was thinking about
And they were holding a torch of fire. I was like, yo, this is some. I'm telling you, that's what I feel about you.
funny.
You be laughing and.
All right. Now, you can pick your periodic table once you have your partner, which is why I didn't tell you to go ahead and get out your periodic table. That way you and your partner can decide which one you want. Okay, you get 2. I would certainly choose the orange one with numbers, because some of the questions, excuse me, are going to refer to protons and neutrons. And because you're going to have to know protons and neutrons, I would want my orange one so that you can look up protons and neutrons. Because if it says something has 4 protons, it still has 4 protons on these clues. It still matches up. So if you look at the back side, these elements match the same elements they match on the periodic table, okay? So the element that's in this position is still going to be the element that matches hydrogen, so it's still going to be a gas. These 4 that are over here in group 18 are still going to match the same properties that the normal gases would have. They're still going to be gases, okay? None of those things have changed. So, if you look on the front side, about where my fingers are, you'll find some letters, okay? I see the letters? Those are the fake elements, the fake ones that you're going to put on the table. So you see how it starts BFT? How many letters are in the grouping BFT? That means BFT can only go in a column that has how many blocks? So it can only go in either group 2, 13, group 17. It cannot go in group 1 or group 18 because it has how many blocks? That's 4. Everybody go with that? Okay. So when you look at DGLZ, DGLZ has how many? 4. So it would have to go in groups what or what? 1 or 18. Everybody go with that? Now, that does not mean that it would go DGLZ It just means that D, G, L, Z are all in that column some way. Everybody good with that? Okay. Now, the clues help you figure out where they go in the column. So if we read the first clue, it says G is a noble gas. That tells you that D, G, L, Z have to be in which column? 18. So if it were me, first of all, I'd do this in pencil. And I would write D, G, L, and Z under group 18. So I know that all 4 of those letters go in group 18. Okay? For the most part, all of the first set of clues help you figure out which column they go with. The bottom set of clues help you figure out where in the column the letters go. Most of the letters have a clue, not all, because if they don't have a clue, you're supposed to use the process of elimination. Okay? Some of them will help you figure out periods. Some of them will help you figure out placement based on this one's bigger than that one, so you know top to bottom. Okay? Now, you may use 2 tables. You and your partner choose the other table you want. You can use your SPDF table. You can use one that has solid liquids and gases on it. It doesn't matter to me. Okay? Choose the one you and your partner feel that you're the weakest on in terms of what you remember and choose that. Okay? So you need to spread yourselves out around the room so that only one partner group is at each counter. Okay? You're working in groups of 2, not 4. So I should not hear you talking to other people. Oh, you want to do it now? You want it by yourself? Now I got to find an odd man partner.
We gonna find.
Who, me?
I wasn't gonna do it, but I don't want it to be as good.
You don't have one?
So what's that we?
The color, no, use your color.
All right, groups of 2.
Use yours.
I guess there, I'm from a great paper.
I don't.
Watch the video. You got your phone?
Yeah.
Go to the website. Put your earbuds in. Yes, ma'am.
Can I steal this too?
You want a bigger one? I'll give you my laptop and go to the website over there. I don't mind.
Can I use this too?
Yeah, as long as you bring it back.
Okay.
Who doesn't have a part?
Oh my God, Miss Wall. I just got in the video.
What?
The video.
It's okay.
No, it's not.
Ariel, you got a phone? Come get a laptop so you can start catching up on yesterday's video. You can have 2 periodic words. Here's the other sheet we did. We did 2 of them. You have both. They were just practice.
What's that? 70? Oh, yeah, okay.
It's gonna be. Okay, question.
What?
Can we draw a staircase?
Can you draw what?
A staircase.
Yes.
Amazing.
Outer shell.
Oh, yeah.
Not necessarily. I mean, it may, it's not. Well, the neutrons don't do anything. So, you know what group it's in? Yeah. Maybe what group is it?
Pardon the interruption. Please admit the students from bus 200 as it just arrived.
That's not even 40 times 18. That's the one. So whatever luck.
Miss Wall,
Yeah,
with the outer shell electron configuration, since we don't have the entire D group.
free in here. Look, they yelling like a crazy person. Oh, look, he was on bus 200?
I got you next.
Really? Yeah? Yeah. All right, Angel. I got you, partner. Angel and Angel.
He doesn't want to do it.
You don't get a vote. It's bed here. Y'all just pull the chair back there somewhere. Use your chair and somebody else's chair. Yes.
I've had lower.
What's his name?
It's just like those things like shrink because they feel together when you get lined I'm talking about
Goes here. And then it says W is the gas.
I think it's only in the
I don't know.
So why?
I've had this
Oh.
Yeah, I'm ready. And it's greater than us.
Not good.
As this A is more metallic, this is either of what? 1, 2, 3, yes.
Oh.
Why is it all fine?
You've been right, right?
So atomic radiation size, right?
So that's the case.
They have lower.
The other two,
I think that.
it's what? It says.
It says. This one is, They have a lower elevation.
How many things like that? I don't know if it's right.
yeah, I think that's what
Yes, they do. So if you said they were solid, they were liquid, they have the same electrons, same neutrons, yes. Yes, yes.
Always.
It's still 5.
Wally, have you stopped working?
What gas? What gas?
Huh? Give her a laptop.
We got 3.
Yeah, that's very hard.
I have a question.
And then it would still be the gas on the periodic table. It's the same properties of what you like.
Wait.
It has to be in the same spot as what you labeled the gas.
No, I remember my reasoning.
Are you taking these back?
Yeah. Thank you, there. What?
Just to look at it.
Looks great. Best I can tell, all the letters are in the right column. That's all I remember. Not a key.
Come on up, please. No, I didn't.
What's the name?
Okay. So you can go first.
The only way I check it was right, it's great.
It's up to you. But then it says that,
So how would you have both of us? So one is supposed to have. When I got like, increases as you go.
I know, I'm really useful, aren't I?
Very.
Let me finish grading these pictures. I'm right. And only a small half stack. It won't take me long to grade these terrible things. Most of them are right. Well, some of them are good, some of them are terrible. That's fine.
You good?
You go faster if they load. Just wait like that. I'm gonna grade this as I finish marking all points for not throwing anything. Follow the instructions. You've got enough. He's off to the side. I get the key for y'all. Do not do that. Had two backwards. See which one you had you and Kay back there.
It's all in the kids.
Same thing.
Let's go over it and see.
Y'all do realize back there that it does not say most potential. Out. Now, Caroline's yelling at me for not being useful. It says least metallic.
I mean, they said, I mean, see, we go, see, we go.
Done? We ready? Are they deciding? They're not. Are y'all coming out there? The student land.
Slightly.
Yeah. That's the same thing as the energy level on the periodic table. Yeah. If I look over at grade, remember, I don't know the order of the letter. All I can basically do is tell you they're in the right columns. But beyond that, I can't be very useful without the key of all the
I'm gonna the yellow that is this is dark. I remember it stopped.
My grandma, yeah.
But I mean, you will yourself Why is this like application?
I'm doing wild.
You done? Hey, great. I called y'all, but that bothers me. What you say? All right, free group still working? Chris, come here this way. Chris. No, sure. Yes. You gotta do some ISS work. Remind myself.
Oh, you're right.
I can honestly say. Don't take it. I got a little afraid of Jimmy. Now, y'all will be the first sub partners who do not have the same answers written down.
What? Yeah, hold on. Before you grab it out, let me make sure I get mine. Yeah, I think we do. I think we do.
I told you it was different. He was like, no, it's not.
Yeah, make sure you got
They agree. I agree.
Uh-oh.
I'd be saying that something.
I know what you're trying to do. Too slow.
She has to look at that. They know we're good trade. I think you just. I'll do that math before I didn't know any fun. Alright, so now I'm down to my OCD group at the back. Alright, so go ahead and pry the paper out of her hand here eventually.
I don't remember this. Oh my God.
Show me.
Should have recorded this. He get on you like that.
Alright, you know
I can't see.
Now, the paper that Chris just gave you is review for your quiz tomorrow. Alright? Are you really not bringing her? Okay.
All we have to do is go
Oh, that's for you. Yeah.
First one's a blog brings me. Oh, it's not. I know it's not.
Alright. Find your notes.
No, you're kidding, right? That's why.
Because I'm ready to move on.
I'm not ready to move on. Give me 5 minutes.
Give me like.
Let's walk. No man left behind.
No man left behind.
Is that the Lexington School motto?
No, that's the Marines, I think.
I was here. I thought it was like no child left behind.
That's President Bush, and he's not been in office in a while. So I don't know what to tell you about all
It's
that.
just sad that I don't know
That's
the
the word they
president.
used to say all the time at Charles England. No.
I just know that George Washington was the first and Obama was the 44th. That's all I know. And I know Abraham, that's not my president. And I know Abraham Lincoln was the president.
What did he say?
He said he said the current president. I said that's not my president.
Unfortunately, he is. He's just an idiot. He is, and today he's just an idiot.
Wait a minute.
And you just can't fix stupid.
I know Abraham Lincoln.
They ought to be able to at least do Washington, Lincoln.
I know Abraham Lincoln was the president. I just
You
don't
can't do FDR, World War II. Franklin Delano Roosevelt.
I don't pay attention to history.
Is this
It's just so boring.
Huh?
I do know murder. Wish I could just play.
That's not the point.
I got an 85.
How can you have an 85 and you can't list anybody but George Washington and Obama?
Because he don't ask about the president.
Football got this year.
Well, not for
He ain't got no.
I don't know.
that was easy because I just read about it. But I don't know them like book of novels. Like they're like who's the third president? I'm gonna tell you like
The paper that Chris gave you is homework if you wish to do it. If you don't wish to do it, it does not matter to me. I'm not grading it. I'm not looking at it.
if I do it, can I get
It is strictly for y'all. Now, quiz is tomorrow. It's on trends. I'm done talking about the periodic table and trends.
Great.
All right. Your quiz is tomorrow on it, and then we're moving on to the bonding today. All right. Now, it is half of the test that we will take after Thanksgiving. Now, for those of you who like titles, we're moving on to bonding.
Well, there
Okay.
are the answers to this on the website.
No, but I'll go over it tomorrow morning.
Do you have like an answer key and I can just write them down?
Yeah, I've got an answer key. I can flip to it if you want. You can get them at the end of class. All right. I think I have the answer key. Yeah, I do. I wrote them down. Now, bonding will take us a little longer than the periodic table. Best guess, about 5 days. All right. Tomorrow, we're going to learn to draw Lewis structures. Some of you will like that, some of you won't. And then Monday and Tuesday, we'll learn to do geometries and polarities. Then we'll learn to draw ionic structures. Now, and then we'll wrap it up early after Thanksgiving. Best guess the test will be about Wednesday after the Thanksgiving holiday. So, what is a bond? I did these, I don't know, a couple of years ago because I had to be out with a sub. So they're typed. It looks a little better than my terrible handwriting, so I still use them. So, a bond is a link between atoms. It results from the mutual attraction of nuclei for electrons. Now, the thing to remember about this is that you have two atoms. And you'll just have to bear with my terrible drawing here. So you have this atom, and they're going to bond, right? This nucleus, got some electrons and some electrons. This nucleus attracts those electrons. This nucleus attracts those electrons. So we're not talking about a nucleus attracting its own electrons. We're talking about a nucleus attracting the electrons in the other atom. So the electrons are being attracted to a nucleus. Now, how those attractions work is where bonding comes from. If you remember some things from maybe 8th grade science, depending on who you have, then you might remember more about bonding. A lot of you are not going to remember any of this, and that's okay. Okay? Now, earlier this semester, we talked about 2 types of bonds. Does anybody remember the 2 types of bonds we talked about?
Covalent
What'd you say? And ionic. Okay? Today, I'm going to add a 3rd type. Okay? Ionic, covalent, and metallic. All right, and we're going to learn about all 3 types. Metallic is the one we'll do the least with because it's the smallest part of your curriculum. But ionic and covalent are the 2 that we really have to broaden our scope with this semester. Okay? Ionic and covalent you know a little bit about, and we've really got to broaden that. Metallic we will do just a little bit. We'll skim the surface with that one.
Why does it look like they're like smears?
Where? Is it blurry?
Like it's
I don't know. Sometimes if the connections get loose, it'll look that way. Is that any better?
Yeah.
Kevin had the cords taped down back here, but they will not stay because of the weight. And so when the tape comes loose, cords fall and it pulls on them. And then,
why don't you use some duct
no, he gave me this plastic tape, but it's not working too well. All right. So what's an ionic bond? Now, the top definition is the one we haven't done yet. Right? If you did this in 8th grade, you probably talked about this definition. It's a bond where the electrons are lost and gained. All right? It's a bond where the electrons are lost and gained. And we'll spend a lot of time with that possibly Tuesday. If not, it'll be after the break. Okay? It's a bond where the electrons are lost and gained. Sometimes we'll say that it's a bond, let me change colors there, that it's a bond between positive and negative ions. All right, some textbooks like that definition. All right, they like that definition because positive ions mean what happened to the electrons?
They lose it.
They lose it. And negative ions mean electrons for what? They were gained. So some books prefer that definition. It means the same thing. All right, one element loses the electrons, one element gains the electrons. Now, that's the definition that we're going to focus on when we talk about how to draw the structures. Now, way back, second week of school maybe, we talked about how to find an ionic bond when we did naming. So, how did we figure out how to determine an ionic bond? We looked at the periodic table, and what did we look up? Whether they were a what or a what? Metal or non-metal. Now, I shouldn't have to draw the periodic table up on that board, should I? Everything that's up there in what color is a what? Blue is a what? No. Everything over there in yellow and orange is a what? Non-metal. Now, when we were doing this, basically if it was green, everything to the left of the staircase we said was a what? metal. If it was on the right of the staircase, we said it was a what?
Oh.
A non-metal. Left was a metal, right was a non-metal. We're still going to use that basic rule. Nothing's going to change today. Now, covalent bonds. Covalent bonds are a bond where electrons are shared. This is where we're going to spend the bulk of our time tomorrow. Okay? And Monday. Possibly Tuesday. Depends on how tomorrow goes. It's a bond where electrons are shared between the atoms. A bond where the electrons are shared between the atoms. Now, how do we figure out if they were covalent bonds? They had to be what? They had to be non-metals, okay? They had to be all non-metals. All right, you caught up with me? Yes? All right, so this is the new one. Metallic bond is a little strange. I warn you ahead of time. All right, an electron is donated to a region in space called the electron C model, like SEA, not the letter C. All right? Now, because this one is a combination of metals or any metal. This tends to confuse people because it can be any metal. For example, if you have aluminum foil at home, which I would imagine every single person in this room has, right? How do we write the formula for aluminum foil? If it's just a metal, it's just aluminum. It's just Al. Okay? That's it. So does it have to be a combination of different elements like it had to be for an ionic bond or a covalent bond? No. Okay? So if you see just Al, that's a metallic bond. It doesn't have to be a fancy formula like it was for covalent or ionic bonds. Or if you have a nickel in your pocket, for example. How do we write the formula for nickel? Ni. That's it. Now, if you have an alloy, okay, a combination of metals, okay, that's called an alloy. Now, most of those have different names. We don't write those as a string of various metals, all right? So a lot of times we call those different names, like stainless steel. Or maybe y'all have some bronze. Okay, we tend to give those other names rather than listing the metals that are in them. All right, even if you have gold, okay? Gold has various levels of gold. I think I talked about this the other day, but I don't remember what class it is. This one? Okay, gold is very soft if you buy 24 karat gold, so you can get 14 or 10 karat gold to strengthen it. But we just buy gold. You don't buy gold to tell people, oh yeah, it's got zinc and copper in it to make it strong, right? Nobody tells people that. You just tell people you got a gold ring. All right, so those are some alloys. Does that make sense? Okay. Does everybody have it then 104? No? All right, so when you got it done. Now, our goal today is to figure out how to tell the difference between the three types of bonds. Now, we can already do it one way, but sometimes when we do it that way, do we always get the right answer? No, we don't. So we have to have another way. Got it? All right. All right, so I want you to tell me the type of bonds in all of those. Now, leave a little space because we're going to come back to these and do them a different way in a little bit. Okay? Even if we don't get it all done today, we'll do it tomorrow. But don't squish it all up in the tiniest amount of space you can, because we're going to come back and do it a different way. Use your periodic table and find me the bond type. Ionic, covalent, or metallic? And don't write on this table that I'm giving you. You can put your name on it if you want, but don't put anything else on it.
What do you do if there's only one non-metal?
What do you think?
Still metallic?
If a non-metal would be metallic.
Would it be covalent?
Yes. And I'm going to explain that in a minute. All right, have we had a chance to try them all? No, need more time? Where are we at? More time? Okay. How about now? You're there, not there, where are we at? I can hear the chorus better than I can y'all. Are we there? Done? I know Sailor said I was intimidating, but I'm trying to be very nice and fast. So, Thank you, Sailor, for asking and answering. All right, so in the first one, what'd you come up with? Okay, I heard covalent, I heard opposite. All right, so if we look at Na, what can you tell me about Na? It's a metal, okay? So that's a metal. It's too wide. All right, so that's a metal. This is a what? It's a non-metal. So that would make it a metal and a non-metal, which makes it what? Makes it ionic. All right, what can you tell me about P? It's a non-metal. Cl is so a non-metal and a non-metal makes it what? Covalent. Okay, what about Ca? Metal, and I is so that would be, all right, what about H? Non-metal, what's F? So that's an covalent. All right, C and H would both be, so that's covalent. All right, so ClCl is the one that Caroline asked about, and I said I would explain. All right, we don't write chlorine and chlorine this way, okay? We just don't write it that way. We write it as Cl2, but Cl2 is chlorine bonded to a chlorine. So that's a non-metal bonded to a what? A non-metal and a non-metal. So if you have a non-metal bonded to a non-metal, what kind of bond is it? It's covalent, okay? Now, the last one is just Cr by itself. So what is Cr by itself? It's a metal. So if it's a metal, it is a metallic bond. Okay? Questions?
What do you do if you have like a metal and a metalloid or a non-metal and a metalloid?
So what now?
What do you do if you have like a metal and a metalloid or a non-metal and a metalloid?
That's where we're going next. There are two in this list that are wrong. But you have no way to know if they're wrong based on what we've just done. Okay? Because if all the state provides is a periodic table, they're going to expect you to do this, and this is the way you predict. Okay? Now, if they provide what I just gave you, there's a more accurate way to determine bond type, which is what we're getting ready to learn. Okay? So, what did I just hand y'all? All right, that's way too much information at one time. Where's my screen? All right, a more definite way to determine bond type is to use, all right, is to use an electronegativity scale. All right, so we're going to learn to find bond type using electronegativity. Okay, so I just handed you a chart of electronegativities. Now, you cannot use this method unless the state includes this in the test question, because you're not going to have this chart on the exam. So they would have to provide some of this information in the actual test question, which they may do. Remember, I don't ever see the exam. I will not be with you when you take the exam. Okay? This is just a technique that you're supposed to be able to use if they provide the information. Now, to use this, you have to know this scale. Before Antoinette tells me she cannot learn this scale, it's a grand total of 3 numbers, one of which you already know or should know. What did I tell you the highest electronegativity was? 4, and who had it? Fluorine. Okay, that's the highest number. All right, 0 is the lowest number on the scale, so you're really only learning 2 numbers. Okay, you're learning the 1.7 and the 0.3. Now, if you fall between 4 and 1.7 on the scale, you're an ionic bond. If you fall between 1.7 and 0.3, you're a polar covalent bond. And if you fall between 0.3 and 0, you're a nonpolar covalent bond. But basically, if you're above 1.7, you're ionic. And if you're below 1.7, you're covalent. So, what on earth are we going to do with this scale? It's easy. We subtract. That's all we do. To determine bond type, you subtract the electronegativity numbers. Okay? To determine the bond type, subtract the electronegativity of each atom. It will be the positive difference. Right? So if you accidentally subtract the little number minus the big number and get a negative number, just take the negative off. It's a positive difference. Did I say use the subscripts anywhere up there? Bonte's shaking his head over there. Nope. Because we don't use the subscripts. All we do is subtract the two numbers and take the positive difference. We do not use the subscripts. Okay? We subtract the numbers. That's it. And then we look to see where they fall on the scale.
Why would you just like see which category it falls in?
That's all we're going to do.
I thought you said we subtract.
Well, we do, because we have to see what the difference is between the two numbers. We can't just look at it and go, oh, you're a 0.3, so you have to, or a 0.4 and go, oh, you're polar covalent. We got to see what the difference is between the two numbers to see which element is pulling more on the electrons. Remember, the electronegativity, well, you weren't here yesterday, but you watched the video. All right, it talks about who's pulling more on the electrons, who's stronger. So the difference is telling us who's pulling harder.
Can you just look at this?
Yeah, we're going to get the numbers off that.
No. Okay.
All right, so if we do one like NaF, okay, and I already put the numbers up there so we didn't even have to look. All right, so Na has what number? 0.9, and F has what number? 4.0. So if we want to figure out what bond type it is, what do we do with the two numbers? We subtract them. So we would say 4 minus 0.9 is 3.1. So what kind of bond would NaF be?
Ionic.
It'd be an ionic bond. Now, if I had something that had, let's just say that we had PCl3, for example. All right, one with a subscript. I would look up P. P has what number? 2 point what? 2.1. Subtract. What's C? L. Is it 3.0?
Yeah.
3.0. All right, I get 0.9. All right, and I took the negative sign off because it's always a positive number. And because it's 0.9, that tells me what about the bond type? Polar covalent. Polar has nothing to do with being cold, by the way.
So if it was just like chlorine, you would just read the chart and then subtract.
All right, so if it's Cl2, all right, what does Cl2 mean?
It's 2 chlorine.
It's 2 chlorine, so it's Cl bonded to a Cl. All right, so you would say 3.0 subtract 3.0, which is what? 0. That's the only one that's a little weird because we don't write Cl bonded to a Cl. Okay, that's the only one that's odd.
It's non-polar covalent.
That would be non-polar covalent, yes. And if you want to abbreviate NPC and PC, you can. All right, so your homework tonight, if you wish, is to do the review for your quiz. All right, this will not be on the quiz tomorrow. So don't come in asking about bonding.
If it just had like a single seat, would you just rename it to?
A single C, you will not have a single C. Notice what is not on that scale. What kind of bond is not on that scale? Metallic. So you will never have a single element to read on that scale. It will always either be ionic, covalent, or, like polar covalent or non-polar covalent. Metallic will never be up there. Right? It's up there. I already looked to it for you.
Oh my God.
Why are you yelling at me?
I'm gonna have to
Why are you not in mental breakdown? I should take you home with me. You would so fit in at my house. Come on out. Pretty sure we'll do this tomorrow. I know, I'm trying to figure out what we're gonna do tomorrow. I'm gonna give you what I think we're gonna do tomorrow in case we don't. Just give it back. Pretty sure we'll do that. And that's
Well,
great.
you know, this. My zipper, not this zipper, this zipper.
Say what?
You help me fix it. My zipper. Bro.
That is not something I can fix. Yeah, well,
Man, somebody.
yeah, it's not his fault. I can't fix those for my own kids. I said that to my husband. All right, this is the one I'm not sure we'll get to tomorrow. It's possible we will get to that tomorrow at the end of class, and it's highly unlikely, but it's possible. This and this, if we don't get to that tomorrow, this and this, I know we will do. This depends on, hey, Ms. Hathaway, depends on tomorrow, okay? And again, they'll be uploaded to the website, so, I don't know where you're going, if you'll have time and want to or not.
We're going to do it.
Okay, so if you, depending on your vacation and whether you get back and want to,
I think I'll come.
okay, you should, because it'll only be 2 days. A lot of it, with Lewis structures will be practice. So, I'll teach, they'll practice because they'll need time to draw the Lewis structures.
With this tardy thing, if there's already one time they have to take that detention?
Yes, and their tardy is an automatic fill out the form, it's 15 minutes. There's no warning.